Hello, students. So today we will be working on chapter 11, and chapter 11 is all about acids and bases. So we'll learn what is an acid, what's a base, what are the reactions that they get involved in, how to name a base or an acid, how to measure the pH, and how to determine if the molecule that we have is a strong acid, a weak acid, a strong base, or a weak base. All of these we will discuss in this chapter. So we'll start with the theories. So there is two theories about the acids. The acid theory is basically um, two theories. The first one is called, oops, that's, uh, the first one is called Arena theory. The second one is called Bronsted-Lowry theory. What is the difference? We will see. So we'll try first one. So the first one, which is Arrhenius theory, basically state that any molecule that has H's at the beginning, it would be an acid. 1H, 2H, 3H, whatever. So for example, HCl, it has hydrogen at the beginning. H2 is O4, has two hydrogen. H3PO4 has three hydrogen. Okay, HF, one hydrogen. All of these are examples of an acid, and they are acids because they have hydrogen. They can donate this hydrogen, and this is according to Arrhenius theory. Okay. For the base, so anything that has at the beginning H, it's an acid. Anything that has at the end OH, like NaOH, AOH, or anything that has at the end OH, Arrhenius theory consider it as base. That's it. So this is basically the Arrhenius theory. Whatever you have in the molecule H, you have an acid. Whenever you have an OH in the molecule, then you have a base. The second theory, or what we call the Bronsted theory, Bronsted-Lowry theory, is a little different. It defines the acid differently. So it defined the acid as an acid is the molecule that gives or donate a hydrogen, or two or three. So any hydrogen in an equation or in a reaction that donate a hydrogen is considered a base. Any molecule that receive this hydrogen is basically a base. Okay, example. We have here actually example in the PowerPoint presentation. Let's pull it out here. Example. So, NH3 plus H2O and it will dissociate in water. So basically the ammonium will dissociate in water to form H3O ion and NH4 ion. So you can see that this molecule here give away hydrogen to the water, and it became a H3O. So this is will consider the acid, and this is will consider the base. It's a practice on a clearer one that we can actually um, see. Um, Pronostic glory theory, HCl, so Na3H2O, ammonium and water, the base, the acid, and here ammonium ion and hydroxide ion. So that you can see that the NH3 became NH4, and this means that the water gave away hydrogen to the NH3 to become NH4, so H2O considered a donor, and that's why it's also considered as acid. And the NH3 received it, so it will considered as a base. And this is the equation when the NH3 dissociated in water. For the HCl, when it's dissociated in water, when you put HCl in water, this is what happened. So the HCl will give away the H to the H2O. So this is a donor because it give away H, and the Cl will stay by itself, and the H2O will become H3O. So H2O will consider as a base. You can see here that water worked as a base in this equation with this molecule, and as an acid with this in this equation with that molecule. And water have a very special case, and this is why water is considered amphoteric substance. Give me one. So it's called amphoteric substance or amphoteric molecule, meaning that, and this is the water, specifically for the water, some other molecule, meaning that it always can be either acid or base. Its nature is neutral, so the water is neutral, but with other solution, it can be an acid or it can be a base according to the other molecule that the water is with. So again, the example here is NH3. When we dissociate it or would put it in water, what will happen is water will give away a hydrogen and to the NH3, and the NH3 will become 3 plus 1 equal 4, plus when this so this is H and OH, so the H went to here, then we still have a negative OH. So because water gave away a hydrogen, we call the water acid according to pronostic theory, and because this molecule here received this H, so we call it base, a base molecule. Those have different words that we will learn in few. So these are the two theories, and to actually define an acid. How to, yes, conjugate acid base pair. What are conjugate acid base pair? So those are the two other molecules that we're talking about. So if this is an acid, if this is will be the base, then this will be the conjugate acid. So this would be, or what we call conjugate acid. Conjugate acid, meaning it has potential to be an acid. And we'll call the OH conjugate. Oh, sorry, it's the opposite. This is a base, so it would be conjugate acid, and this is conjugate base. So it has potential to be a base. So these are the conjugate acid and bases. So here you see, if, for example, this here acid, because it starts with an H. So this is an acid dissociated in water. So it will give away the H to the water and will leave the F by itself. So the F by itself and the water receive one more hydrogen. So we call the one that received the hydrogen we call, or that has potential to be an acid, we call conjugate acid. The other one is called conjugate base. If I asked you what is the conjugate acid base pairs, so the first pair will be HF and F, conjugate acid and conjugate base, and then the other base and conjugate acid would be the other two. Here you go. Let me show you. Here. So let's practice here. Write the conjugate base for each of the following. HBr. So it will dissociate into H and Br. H2S. It will dissociate into an H and HS. H2CO3, one H, and then HCO3. Write the conjugate acid in each. So conjugate acids in these two will form HNO2. These two will form NH4. With these two, it will form the water molecule. The second thing here is identify the set that contain acid-base conjugate pairs. So look at this. Are these acid-base conjugate pair? Yeah, you can tell that if this give away one, then this is the correct. They are related. If you look here, would you think that this is an acid-base conjugate? No, because if this give away one hydrogen, then this should be HCO3. HCl and ClO4, they are totally not related to each other at all. HS and H2S, yes, if this H give away one, it will be H2S. These two, the same thing. The difference between them, one hydrogen atom. So let's get this. So base and conjugate acid. Let's try to write the acid-base conjugate. So look here at this equation. You can see that this has an H. So this has a potential to give away hydrogen. So this would be the acid, and